All right, welcome to another video here. So today we're going to talk about integrating by substitution. So often if this is called a U substitution because a lot of the times people use the letter U when they're substituting, but that's not like the official name. I rarely ever use U probably. So anyways, the idea is that you are actually working with the chain rule in reverse. So what we'll be dealing with is sort of this idea of like there's an inside function and we see the derivative of that inside function also within our problem. So let's get started just right away with this first one. We want to take the integral of x cubed times cosine of x to the fourth plus 2. So the first thing I notice is that this inside function, x to the fourth plus 2, has a derivative of 4x cubed. And I have an x cubed right here. So that means that this basically was the result of a chain rule problem. And so I need to figure out what it is. Now, some people can just sort of intuit it and come up with the answer, but a lot of us need to sort of see the pieces sort of fall into place. So let's start with creating an equation to help us make a substitution. So we'll call A x to the fourth plus 2, okay? Which means that's the derivative of A with respect to x is 4x cubed. So in a moment here, I'm going to be able to make a substitution for this x to the fourth plus 2 with A. And my goal is going to be to put everything else in terms of A. Well, that means that I still have this and this that have x's in them and not a's. So I'm going to have to find a way to represent that. So with this in mind, what I've got going on here, I can see I have an x cubed and a dx. Those are the two pieces. So I'm going to isolate those and make a substitution so that way we're all in terms of a. So the first thing I'll do here is I'll multiply both sides by dx. So we got 4x cubed dx. And this part right here is what I want to isolate. So now I'll go ahead and multiply both sides by 1/4. And so now I have something I can substitute. X cubed dx can be replaced with 1/4 dA. So let's do it. So I'm going to come back up here and I'm going to go integral of, and I try to be like sometimes cute with this. So x cubed coming out and replace with a fourth, and then the dx on the end will be replaced with a dA. So I took care of this substitution. And then, of course, I can substitute this cosine of, and instead of x to the fourth plus 2, I can substitute in a because of that statement there. And now I'm going to actually evaluate this. So I'm going to first pull out that fourth just because I can. So that'll be a thing you'll sort of notice is that when you're going through this, you can do that. And then I'm going to now integrate. So the antiderivative of cosine is going to be sine of A plus a constant. And now to finish it off, I want to bring it back in terms of x. So instead of a, I will substitute in 1/4 sine of x to the fourth plus 2 plus a constant. And now you can see that if you were to take the derivative of this answer here, you would have to use the chain rule. So it would be cosine of this stuff. And then the derivative of this inside is 4x cubed. Well, when you multiply that by a fourth, you'll just have x cubed. Derivative of a constant, of course, is 0. So there you have it. That is our first integrating by substitution problem. So chain rule in reverse. Let's do another one here. So this one, the inside function is 2x plus 1. And for a moment, you might be like, I don't see its derivative anywhere. And that's technically correct. You don't see its derivative anywhere, but you can still use substitution on this because the derivative of this inside function is a constant. And so this will allow us to sort of see how to sort of compensate for that constant here. So if we let b be the 2x plus 1, so I've got a substitution ready for that. The only thing I need to replace now is this dx. So again, we'll take the derivative of both sides with respect to x. And now I'm going to isolate dx because that's the only thing I need to substitute out. So db equals 2dx, which means that half db equals dx. And now I have a thing I can substitute in. So let's do it. So this is going to be equivalent to 1/2 the square root of b db. So you can see that's the square root of b, so the 2x plus 1. And then dx is half times db. I put the half in front just because that's where I want to put it. All this is being multiplied, so the order in which you write it is not that important. But typically, obviously, db dx goes at the end. So now I will pull out that half there, and I'll rewrite the square root of b as b to the 1/2 because that's going to make it easier for me to see how to actually evaluate this. And so now I'll do it. So I got half times the antiderivative of that will be, well, we're going to get a b to the 3/2 since I'm adding 1, and it'll be 1 over 3/2 plus a constant. That's the same thing as half times 2/3 b to the 3/2 plus a constant, which gets me 1/3. And now I'll go ahead and bring back in what the b is. So that is 2x plus 1 to the 3/2 plus a constant. And there you have it. And again, you can take the derivative of this, use the chain rule, and see that you get this thing right here. Okay. Next one. Let's take a look at this one here. So the inside function is going to be down here in the denominator. So the derivative of that is negative 8x. Well, I have an x as a factor there, so that's going to be what we'll do here. So we'll go, let's go with a g. So g equals 1 minus 4x squared. So the derivative of that is negative 8x. We want to isolate x dx. That's what's left over. So that's going to be a dg equals negative 8x dx. Divide both sides by a negative 8. And so we get this. All right, so let's make our substitutions here. So the integral. All right, replace the x with negative 1/8. The bottom will just be the square root of negative g, or sorry, just g, square root of g, times dg. So again, you see it's negative 1/8 dg, and then this over the square root of that. Okay, just as before, let's pull out the negative 1/8 since it's a constant multiple. And I'll rewrite this as g to the negative 1/2 dg to, again, really emphasize my use of the power rule. So if we integrate, take the antiderivative, we are going to get g to the positive 1/2, and its coefficient will be 1 over the positive 1/2 plus a constant. That is the same thing as negative 1/8 times 2, g to the 1/2 plus a constant. And now we'll simplify and then replug in g, negative 1/4 when you multiply that together, times 1 minus 4x squared to the 1/2 plus a constant. And once again, if you take the derivative of that, you will get this. You should check it out yourself. I leave that to you, okay? After this video, go back through and double check that all of these, when you take the derivative of the final answer, you definitely get what you started with. Last one, This one's sneaky because it's like, what's the inside function? And I don't see its derivative. It's just a single thing. Well, that's because we haven't thought about other ways to write this. So tangent, of course, is equivalent to sine of x over cosine of x. All right. And so now we can see that there is some function and its derivative. We got to choose carefully here, okay? Because, yes, the derivative of sine is cosine, and the derivative of cosine is negative sine, so you have to choose carefully. The thing to keep in mind is that what you want to have happen is that when you take the derivative, you'll always end up with a product times dx. So sine x dx, that's going to be the thing we're going to end up isolating here. We're going to make a first substitution for cosine, and then find the second substitution there that will be a product. It's always a product. Dx is never being divided by, it's always times dx, because if you remember, this represents the base length of the little rectangles. So let's make this substitution here and find a, oh, I used u. Look at me. I said I don't really use it, and then I just sort of used it. So we'll go with it, u. So we'll take the derivative of this. This is du over dx equals negative sine x. Move over the dx. And we don't want negative sign, so it'll be negative 1 du equals sine x dx. Okay, so let's make these substitutions here. So the integral of, how about I pause for a moment and you see if you can figure out what goes where. Try to anticipate what the next step will look like, and then I will resume in just a few seconds. All right, so here's what we're going to have. We're going to have negative 1 over u times du. So cosine goes in there, and then sine x dx is negative 1 du. So there we have that. Great, and so now we'll yank out that negative. The antiderivative of 1 over u is the natural log of the absolute value of u plus a constant. And then substitute back in negative natural log of, what was our, oh yeah, absolute value of cosine x plus a constant. There you have it. You can use some x or logarithmic properties here because technically that's a negative 1. So like that's an acceptable answer, but I wanted to show you that also the natural log of cosine of x to the negative 1 is a way to write that as well. This is not saying the inverse of cosine though. This is actually an exponent of negative 1, meaning the reciprocal. And the reciprocal of cosine, of course, is secant. So another way you could write your answer would be like this as well, and it would be 100% correct. So kind of cool. So 3 different ways to write the answer that are all correct. All right, so that is substitution. So you're looking for an inside function and its derivative, more or less. It's okay to be off by a factor, like negative 8, being off by a negative, being off by a 2, being off by a 4 times, but you can't be off by anything else other than just a common multiple, a constant multiple, sorry. So please take the survey, and we will talk about this in class and work on it